Across the world, emergencies and catastrophes strike at the most unexpected of times. In rural areas with undeveloped infrastructure, this can lead to communities being left stranded and untreated, causing humanitarian disasters. As a result, the United Nations Humanitarian Aid Service has commissioned a new fleet of aid jets to service remote areas with small airports. But the question is, who will design these jets? Fortunately, in the heart of the United States, at the University of Kansas, inside room G400 of Leap Hall, a group of dedicated students have taken it upon themselves to tackle this unique challenge. To achieve this, they have formed a brand new venture called Bayflow, the off-brand version of Gulfstream. Their task: design a light jet capable of Mach 0.85, or 561 miles per hour, which is over twice the maximum speed of the Bugatti Veyron. It should be able to climb at a rate of 3,500 feet per minute, or 40 miles per hour, and reach up to 45,000 feet in altitude, 36 times the height of the Empire State Building. In addition, it must take off with a maximum length of 4,000 feet, be able to fly for 2,500 nautical miles, a little further than San Francisco to New York, and land in only 3,600 feet. Lastly, the aircraft must carry 6 to 8 passengers, hold 500 pounds of medical supplies, and 500 pounds of luggage. After reviewing these design specifications, the team assembled to research and strategize. Competitor aircraft were analyzed, design choices were considered, and sketches were drafted. At this point, the aircraft was split into several subsections, which were then assigned to the team members. Over the following days, the team conducted detailed research, finalizing their design decisions. Here are some important highlights.
We took our inspiration from the Pilatus PC-24 jetliner. We scaled it up so that the body will measure 60 feet long and have a diameter of 7 feet. It gives it a little more headroom and a little more cargo space. The cross-section is circular so that it can handle the high altitude. It's a lot stronger. The body of the aircraft goes from the cockpit to the passenger area, some cargo on the side and some cargo underneath, and then it tapers off to the end of the tail. And this allows for the aerodynamics. The jet is going at a high speed. You have to take that into consideration.
For the wing, which creates lift to keep the aircraft in the sky, we decided on a wingspan of 65 feet, which is similar to other aircraft in its class. It is mounted low on the aircraft body and is angled backwards, which helps the aircraft travel faster.
Okay. In the back of the plane, we have a T-tail stabilizer, which is more stable, and also it mount the horizontal tail higher up so that it prevents the disruptive air from the wing and the engine coming through it.
Hey y'all, we have 4 different control surfaces which help the pilot control the aircraft. Our first one is our flap, which is most inboard towards the body of the plane. The flap helps reduce our takeoff length so we can have a shorter runway. Next, we have our ailerons, which are about on the tips of the wing, which control the roll of the airplane and keep it level. Next, on our tail, we have our elevator, which helps the plane tilt up and down for ascension and descension. And then finally, on our tail as well, we have our rudder, which lets the plane move left and right, or turn left and right, and keep the direction in the way the pilot wants it to go.
For our aircraft, we have 2 turbofan engines, which is used to move the aircraft forward. The engines are mounted towards the end of the aircraft on each side. For each engine, it produces 4,200 pounds of thrust. The length of the engine is 68 inches, which, fun fact, is the size of a male gorilla. However, the engine weighs twice as much of a gorilla.
So inside the aircraft, we have a cockpit with the same buttons and controls as Gulfstreams because we're Bayflow. Of course, you get the same stuff for cheaper. Behind the cockpit, you have the passenger area with a bed and seating for about 6 to 8 passengers. And then behind that, you have the bathroom with the toilet and sink, along with storage for medical supplies. And underneath the floor, we have storage for luggage.
With all this important research, the team then regrouped to share their ideas and integrate them together into a single harmonious aircraft. Then, with the aircraft design finalized, the team could finally begin modeling in the CAD software Siemens NX.
To CAD the fuselage, I took the preliminary sketch and design that our group had. I marked out points of interest, such as the cockpit, the hatch, the wing, places like that, and I used that information to make datum planes. Those datum planes on the datum plane, I was able to make a sketch that would predict where the craft would be, and then use through curves to connect those sketches. Then for the nose, the tail, and the belly, I used a spline and again through curves. Lastly, I cut out sections using trim sheet for the cockpit, the windows, and the hatches, and made separate components for the hatches and windows and cockpit in a different file so that they can be updated separately.
To model the wing, I first started by importing airfoil geometry from the internet. I then made datum planes at the root and tip and used the through curves tool to model the wing surfaces. Next, I used the through curves tool again to make the winglets. And lastly, I used the through curves mesh tool to create the fairings to mount the wing to the rest of the aircraft body.
To make the T-tail, I first get the airfoil shape online, and then after that and then I import it for the bottom part and the upper part, and then after that I use through curve to create the surface of it, and then after that I do the same thing for the horizontal tail, and also I add cap on here and here, and then after that I use another through curve to make the fairing for the horizontal tail and the vertical tail, and another thing would be adding mesh through curve for the vertical tail and the body.
So the first step for creating our control surfaces was importing the wing and the tail geometry, and then cutting out little sections for our control surfaces. Next was forming our control surfaces where we wanted them with an offset, and then attaching them to the wing and the tail respectively. As you can see here, we have our flaps, we have our aileron, we have a rudder, and we have our elevator all formed and attached to their respective surface.
To create Pratt & Whitney 545 turbofan engine, I created curves and points to make the outer surface of the engine core. I then created the fan blades to make up the fan, and then I created the nacelle. And then after that, I created the pylon, which was to mount to the aircraft.
To model the interior parts of the airplane, 2D sketches arranged 3D parts, and corners were rounded where they needed to be. Here, like I said, is the control panel. It's just like Gulfstream's because we're Bayflow. For the pilots, we have these sports car-inspired black leather seats with a logo exclusive to this airplane only. In the passenger area, we have red tufted leather seats with a mahogany base and seat controls. Over here, we have the bed made of cotton with chrome trim and a room for a stretcher on top. In the back of the airplane, we have a bathroom with a carbon fiber toilet, a chrome toilet seat, and a red flush button, along with a chrome bidet, courtesy of Bradley, and a chrome sink with storage on the other side of this wall.
With all aircraft sections complete, the last step in the design process was to assemble them together. Using the assembly module and NX, all parts were linked together with appropriate degrees of freedom added for control surfaces, doors, hatches, and other features. And there you go, a complete 3D CAD model of a light humanitarian aid jet. Its name, Soteria, after the Greek goddess of safety, salvation, and preservation from harm. Ready for quick deployment across the world, providing hope and refuge for those struck by disaster. While aerospace engineering is challenging, it can be incredibly rewarding. With the right knowledge and tools at hand, aerospace engineers can design systems that improve the lives of everyday people. And fortunately, with a proper education, almost anyone can learn it. That's why we encourage you to explore an education in aerospace engineering at the University of Kansas.
For cargo, let's do that again.
Bayflow's plane because of course.
And it's mounted on each aircraft. We have 2 turbofan engines. This is used to push. The engine produces 40 to 100,000 pounds of force.
Whoa!
Wait, does it start the recording or not? Wait. Please start.
Okay. I first started by importing It is mounted low on the
Low on the fuselage.
Yeah, low.
Can you do it faster?
What?
Can you do it faster? In the back of the